So, hello, everybody. There's a number of you that are having some trouble with one of the problem set questions in problem set 2 regarding a graphing comparison. That is comparing two frequency or relative frequency distributions, comparing two distributions. How is it that we view these? So, I've gone ahead and made a little sample question or practice question, and I'm going to go through um, the logic of this question and then point out a few things and show you a few things about that. So I have a set of data here. This is some data that I collected during an experiment, and I might want to summarize this in a frequency distribution. So there are a lot of numbers here. There are 1 numbers here, or so on and so forth, and they go from a high of 71 to the smallest value of 21. So that's a lot of scores, and we want to summarize these. And you might think, oh, all I have to do is count the number, the frequency of 21s, the frequency of 22s, the frequency of 23s, the frequency of 24s, 25s, 26s, and so on, and that you would be correct in that, but then incorrect in another way, and that is that you still haven't summarized it. If you have 50 values in your frequency distribution, you haven't adequately summarized the distribution. So the next step in the logic of this is to think about how we might group the intervals then. So what we want to do is we want to take the scores 21, 22, 23, 24, and 25 and put them in a group. And that will be an interval. And then we'll have another interval that goes from 26 to 20 or to 30, and another interval that goes from 31 to 35, and another interval goes from 36 to 40, and so on and so forth. And if we count those, then we can see the shape of the distribution, maybe talk a little bit about it. But how is it that I arrive at these intervals? I mean, what is the process by which I go through that? Well, in the book we describe it, in the workbook we describe it as 2. As well. So you need to calculate the minimum value, the maximum value, and the range. And once you get the range, you want to divide by 7 or 8 and 15. And then you want to select a whole number in between those two numbers. So I want a whole number in between 3.3 repeat and 7.14. Now, it turns out that I could select 4 or 6. 4, 5, and 6 all meet those qualifications. That is a whole number in between 3.3 and 7.1. The problem is that 4 isn't a very intuitive number. It's okay, and 6 is kind of odd too, but 5 is a very, we tend to count in fives and think in fives, so 5 is a wonderful number. So that's why I selected these intervals. I started with the minimum value, 21, and then I used an interval width of 5, so 21, 22, 23, 24, 25. So 21 to 25 has 5 values in it. 26 to 30 has 5 values. And then I just went and counted how many values are between 21 and 25. How many values are between 26 and 30? How many values are between 31 and 35, and so on and so forth. And that's my frequency column here. So here's my frequency distribution, my intervals, frequencies. These are cumulative frequencies, so this tells me that there are 2 values. This number right here tells me that there are 2 values at or below 35. There are 26 values at or below 60. This is the relative frequency then. I've taken the frequencies and divided by the total. So 1 divided by 31 is 0.032, and so on and so forth. And I just dragged that formula so that it calculated the relative frequencies for these intervals and the cumulative relative frequencies. Now your first task was to plot the frequency, construct a graphical representation of the frequency distribution. And in Excel, the easiest way to do this is to select the range like that and then just add a graph. That is a frequency distribution of this particular set of scores. And you can see it's sort of hump-shaped. It's centered around whatever this interval is, and we can beautify this a little bit. We can change various properties of this. One of the problems that we're encountering in using Excel in doing some of these things is that there's not cross-platform consistency all the time. I'm doing this on a Mac right now, And your Excel isn't going to look exactly like this. In fact, the PC version with all those ribbons they call them drives me crazy when I see it. It's counterintuitive. So I'm teaching you a way to do these things that should be not so platform specific. Um, so that's the easiest way, is to select a range and add a graph. So if we do a relative frequency distribution, I select the relative frequency values and then I add a graph, and I'm going to choose that one. Now, you may look at these two graphs and go, Matt, they look exactly the same, and you'd be right. Frequency distribution and a relative frequency distribution look exactly the same except for what is on the y-axis. Notice these values go from 0 to 8, whereas these values go from 0 to 0.25. So relative frequencies are going to be are proportions, and proportions we know as go from 0 to 1. Likewise, we can do cumulative frequency distribution. Here's our cumulative frequency distribution. I'm going to put it over here just for now, and we'll look at that. And then if I were to construct a cumulative relative frequency distribution, I would get something like that, and you would say, boy, Matt, they look exactly alike, and I would say, yes, they are exactly the same shape, the same relative relationships hold, except the y-axis values are different. Okay, now in Excel, one of the things that I can do, is I can add a series to a graph. So when I select a graph, I'll just show you this real quickly. In a PC, you have to go and sort of find how to add data or add a series. If I were to add a relative frequency measures to this graph like this, let's say I add that plot, you might go, that doesn't make any sense. Well, what is this? These values all look like 0. And I would say, yes, you're right, because remember, relative frequency values are between 0 and 1. So it's plotting all of these values that are between 0 and the highest number is 0.22. So you're not going to see anything. So plotting frequency and relative frequency on the same graph makes no sense at all. Okay? All right, so I'm just going to delete that series. That's one part of the problem in your problem set. In sheet 2 here, I have a second set of data. Here's set B, and it has 52 scores or something like that. Yeah, 52 scores. I've done the same thing. I've calculated the minimum, I've calculated the range, and the max and the range, and then I've divided that range by 7 and by 15. And it turns out that I can use the same interval with 5. So I start with the smallest value, 30, and I go 30 to 34, 35 to 39, and do the same thing that I've done even with set A. So this tells me that there are 7 values between 40 and 44, and then I've done the same sort of plots. Here's the frequency plot, here's the relative frequency plot, here's the cumulative frequency plot, here's the cumulative relative frequency plot. And if you look at the two plots, the values on the y-axis. Now the next question it asks you is to compare these two distributions. Now I think the easiest way to do this is to copy and paste the various values next to one another, select them, and then make a graph. So if we wanted to compare, we might want to compare. So I'm going to copy this. I insert it in a new page, and now what I'm going to do is I'm going to paste them, but I'm going to make sure I just paste the values. I don't want to paste anything else. So this is really the frequency of the A set. I'm going to distinguish it, and then I'm going to come here and I'm going to copy and paste the frequencies for the B set. And I'm going to paste special again, because I just want the values. There might be formulas in there. Okay, so it looks like I got my frequency values, and then one way to compare them would be to select these two, and if you just select the frequency values and add a line there, you have your comparison. Okay, so this graph compares the two distributions. And I would look at this and say, you are absolutely wrong in doing that. That's absolutely wrong. And I'll tell you why. It's because when we look at the intervals for the frequency of the A set, and we look at the intervals for the B set, they are different. So I can't compare this 1 and this 2 because they're looking at different values of the interval. Now you might say, oh, this includes 30, so maybe I want to move these all down a little bit, and maybe they'll line up a little bit better at 30, 30. But I ask you then, which interval does the score 30 go into? In the A set, it goes into this interval, but in the B set, it goes into this interval. So when you have different intervals, you can't compare two data sets. You have to make sure that the intervals are exactly the same. So that's what I've done over here, is I've reconstructed the distribution so that the intervals are the same. Now, in some cases, the frequency of the number of scores in set B that are between 21 and 25 is 0. I might have intervals with 0. I've used the intervals from the A data set because they seem the most likely, the most they seem the most they're perfectly fine. In other words. So now in this case, if I select these and input a graph, this is the comparison distribution I'll get. Now let's look again at although I deleted it, let's move these back. Let's get rid of this. And just for grins and giggles, let's compare these two graphs. And as you can see, they are discriminably different. They're very different, in fact. I would say that, on the small end here, the frequencies are about the same. It's only at the larger scores that the B set has a larger number. Here, this is not a valid comparison. Okay. But even when we look at this graph, what we see is this is not a valid comparison either. It's not a valid comparison because we have 52 scores in the B set and 31 scores in the A set. And of course we're going to have a higher frequency of certain intervals of scores, like here, 6 and 5, here, 10 and 2, because we have more total observations. So that might obscure differences or similarities based on the fact that we just have a greater number. We need to standardize these frequency measures so that we can do a valid comparison. And that's what relative frequency accomplishes. So when we come here and plot the relative frequencies, what we see is somewhat, just want to move my graph here. When we compare these two graphs now, we can see that this is a much fairer comparison. Now, I remember I told you that, hey, relative frequencies and frequencies should look the same. They do, but the scales are going to change. And when we put them on the same scale, that's when we're going to have the best comparison. The shapes are the same, except this one's going to be expanded a little bit relative to the red series. The blue series looks a little taller, but the shapes are in fact exactly the same. When we compare graphs or compare distributions, we want to compare relative frequencies, so we eliminate the influence of a higher number of scores. This is the comparison that we ultimately want. This is the best comparison that we can have. Relative frequencies of the same intervals. Perfect. Beautiful.